Alright, let's do some Mathity-Math. It says here, find the straight line that passes through the point of intersection of lines L1 and L2, okay, those are them right there, and is also perpendicular to, okay, line 3. Awesome. It says give your answer in y equals mx plus b form. Okay, we can handle this. Okay, so the first thing, when you're trying to find the point of intersection of two lines, you can handle this a couple different ways. One way is you could set everything equal to y, and then set the y's equal, and isolate like that. You could totally do that. Or you could do these at the same time and then eliminate. I'm going to show you guys how to eliminate. It's a pretty handy little trick here. And I want to eliminate because I'm seeing these are very similar, and that just tells me go ahead and give it a shot at elimination. So line 1, I say negative 5x plus y plus 6 is 0. Line 2 says negative 2x plus y minus 15 is 0. Okay, and so when we remember that, you know, when two lines intersect, they are the same thing. They combine into the exact same thing. They're just one thing. When we can combine these points, but we want to combine them. I'm sorry, we can combine these equations, but we want to combine them so that something eliminates. And as it stands, nothing would eliminate. But if I multiply this bottom equation by negative 1, it puts me in a unique position to eliminate. So watch. I say negative 5x. At this point, I'm just copying. Let me draw. Okay. Plus 6 is 0. Okay, negative 1 times negative 2x is positive 2x. Negative 1 times y is negative y. And negative 1 times negative 15 is positive 15. And 0 times negative 1 is still 0. Now, if I combine these, negative 5x and 2x, when combined, give you 3x. You see here the y's, a positive y and a negative y, when they combine, they eliminate. They go away. Poof, they're gone. So that's gone. And then 6 and 15, when they combine, gives you 21. And 0 and 0, when they combine, give you 0. And just like that, we only have one variable to deal with, and our life got a lot easier. Now just doing basic linear algebra, 3x is negative, oh, you know what? Negative 5 and 2x is negative 3. Excuse me. There we go. Negative 3x minus 21, and then negative 21 divided by negative 3 is a positive 7. And that is actually the x-coordinate of our point of intersection. To find the y-coordinate of the point of intersection, you just plug this x in to L1 or L2. It won't make a difference. I'm actually going to do both just to double check I didn't make a silly mistake. And it can happen, so why not just give it a quick check? So I just put into line 1 7 instead of x. So this writes out to say negative 5 times 7 plus y plus 6 equals 0. And again, now you can see I only have one variable. So this is just now basic linear algebra. And we can go from there. I subtract 6 from both sides. And then I add 35 to both sides. 35 minus 6 is a positive 29. So there we go. Now I know that my point of intersection is 7, 29. Now actually I want to do the second line too, just to be safe, because you know sometimes we make silly mistakes. I did it right here myself, right? So I'm going to quickly double check. If I plug in the 7, I would get negative 14 plus y minus 15 is 0. Okay, I add 15 and I add 14 to both sides, 15 and 14. It does, in fact, make 29. Great. Okay, so now we know that our point of intersection, I'll just put it right here, our point of intersection for L1 and L2 is 7, 29. Okay, that's the first step. So we know that the line we're going to make, whatever it is, it's going to pass through this point. And this is the x-coordinate, and this is the y-coordinate. And that's going to be really important for us later on. The next part is, it says, well, you know what? There's another rule. The other rule is that your line needs to be perpendicular to line 3. Oops, sorry about that. Okay, it has to be perpendicular to line 3. Now, here's the important part about this. Let me separate these out. Okay, so when we try to find our slope, when a slope is perpendicular, it's the opposite reciprocal, right? And so we got to take the slope from line 3, but you have to be careful here. Our inclination is to just pull it straight from the x, right? But we have to think about this. we need to move this into slope-intercept form because it will change the sign and if we don't. So we got to make sure we isolate y and then pull the m, okay? So if you think about this, let's put it right over here. I have negative 1/3 x, okay, plus y minus 20 equals 0. And I can't use this yet because it's not in the right form. So I'm going to add 20 to both sides. Negative 1/3 x plus y equals 20. Great. I'm going to add this to both sides. Space here. Okay. So I get y is positive 1/3 x plus 20. This is L3. This is the same L3 I just put into slope-intercept form. But now I know the intercept, not really what I need, but I now know the slope. So my line, the one I'm trying to find, we said is perpendicular to line 3. So if line 3 slope is 1/3, my line, its slope is going to be negative 3, the opposite reciprocal. So for my answer, I now know it's going to be y is negative 3 x plus b. And actually, all I have to do now is find my y-intercept, my b, and I got it. To do that, I need to get a value for y and a value for x that I know this line will hit. Well, I know that. They told me this line goes through this point. So I just plug this point in, and then we're home free. So my y is 29. My x is 7. Here we go. 29 equals negative 21 plus b. Add 21 to both sides. What's that going to give you? 50 equals b. And there you go. Your b is 50. So your final answer, my line, is y equals negative 3x plus 50. Voila. Good job. You did it. All right. As always, you got any questions or something you want to tell me, leave it in the comments below. And don't forget to subscribe if you want to be notified when more Mathity-Math is coming your way. Thank you. Goodbye.